So hi everyone, my name is Alice. I'm a Kubernetes maintainer and I recently moved to CoreOS team. And we have here Herman, that is virtiofs maintainer. And today we're going to talk about a few patterns how you can delegate privileges to containers. So just very briefly, the security mechanisms that are standardly used for container. So of course, namespace is C group. That's basically what a container is. Then we have the capability, second filter, and privileged users. And for rootless container, we want to drop all the capabilities. We have a default second filter that is coming with the OCI runtime that is defining the allowed and denied syscalls. And we want to run unprivileged user inside and outside the container. So during this presentation, we are focusing on a real and concrete use case that we have faced for KubeVirt. So for those of you that are not familiar with KubeVirt, KubeVirt is basically a Kubernetes extension to run virtual machines. So it uses all the goodies of Kubernetes, like controller, custom resources, and operators. But this is not what this talk is about. So in this talk, we are going to focus especially on two pods that KubeVirt uses. So the blue one is the unprivileged one. It's called Virt Launcher. And it's basically where the VM is deployed. So you can see that the main container is called compute. It has the guest. It is running using libvirt and QEMU. So the privileged component is the red one, and it's called virt endless. So basically, this is the container that is running on every node, and it's responsible to perform the privilege operation on the node. So the use case that we are focusing on, it's a file system. So file system volume is basically a directory that can be passed directly to the guest. So in order to do this, we use an external process from QEMU that's called virtiofs, that is basically doing, thanks to VOS user protocol, this translation. So a couple of principles and goals that we want to follow while we deploy virtiofs in Virt Launcher. So first of all, the Virt Launcher pod is not trusted, and it's created by the KubeVirt controller. So basically, we consider the guest as an untrusted workload. virtiofs is launched alongside the main container in Virt Launcher pod, and it's deployed in its own container, so its own namespace and C group. The requirement that we want to follow for virtiofs is that virtiofs process need to consume the resources that are accounted on Virt Launcher pod, and the lifetime of virtiofs is coupled to the lifetime of the VM. So those principles, please keep it in mind, because it will come several times during the presentation. So now I will hand it over to Herman.
OK. So virtuofsd is a device, a virtual host device that uses virtuio queues to communicate with the VM using the fuse protocol. Basically, the only use is to share some directory from the host to the VM. So virtuofsd can be run with privilege and without privilege. But without privilege, we have some limitations. So for example, since we use fuse, every access that you do in the guest VMs or the shared directory, those access, the inode and the D entry, are cached in the kernel. So, and then all the operation, like open or read or whatever, is requested to the virtuofsd using a fuse ID that we call here the inode ID. So virtuofsd need to have something to map that inode ID with a real inode or with a real file that is in the shared directory. So one of the options that we have is the file descriptors. That is the only option that we have if we are completely unprivileged, but those have some problems. One is very easy for us to reach the limit of open files, because even if you list all the files inside of the shared directory, we receive a request for any of those, and those access are cached in the guest kernel, so we need to open all those files. And also, we need to keep those files open, so that have some problem with unlinking, especially if we are using NFS, and they will fire the silly rename stuff that is very annoying if you need to manage like a large NFS volume. There is another option that is file handles. That is better for us, but that requires privilege. Basically, it's pure data. Basically, we get the real inode from the file system, and well, the file handle is the inode plus generating number that can check if the inode was reused. But that has another problem. That is, we require some privileges because those file handles can be forged. So basically, if you can forge the file handle of the root file system, you can read anything in that file system. And also requires some file system support, but that is not really an issue currently because most of the file systems support file handlers. That is for the normal operation, but in the context of KubeVirt, we also need to do line migration. It means moving one running VM to a different host while we are serving the file system, the files to the guest. So we need to serialize and deserialize all the internal state of virtuofsd. I give that internal state to QEMU to put in the migration stream and go to the target host. We can do it using only unprivileged operation, that is collecting all the file path and move it to the next one. But I have a lot of inconvenience and a lot of corner cases, and especially it's not very good to handle if a different VM is deleting or renaming some files while one of the VM is migrating. So that could be very problematic. So the only robust way that we have is to use file handlers. But again, that requires some privileges. So one of the solutions that we got before is to just make the virtuofsd container privileged, and that's fine. The problem is, it's the simplest solution, but it's not always possible. Also, you are trusting the user because the user, we said before that the Virt launcher is not trusted, so you can enter to that container and get like a root shell. That is one. The other is have like a this privileged container, but in a different namespace that maybe root containers are allowed, but that also makes all the orchestration more complicated because now it's very difficult to link the VM lifetime with the virtuofsd last time. Basically, if the VM dies, virtuofsd should die. So it makes everything more complicated, and also it means that in some configuration of Kubernetes that will not be possible because of the security standard and stuff.
Okay, so another option is that we basically split the privilege operation in a separate daemon. So it's not the option that we choose, but it's already a pattern that it's already using QEMU. So with this approach, you basically need to refactor your application and completely separate the privilege operation from the standard flow. This is done, for example, for privilege SCSI IOCTL. So QEMU has a separate daemon called the PR helper, and this is what we are using in KubeVirt. So in this case, they are talking through UNIX socket. And basically, QEMU is delegating to the PR helper the privilege operation that in this case are the SCSI IOCTL. So the advantages of this approach are that you have two separate containers. So and respect the OCI container boundaries. We are going to see this more for the fourth solution. You have a clear separation of who is doing privilege operations. But on the other hand, you need to implement a new protocol, especially if it doesn't exist. It's an heavy refactoring of your application, especially if it's already existing. You need to separate parts of the two containers to handle just died. And the other thing is that if we separate the privilege operation, those operations are not consuming the resources that are accounted on Virt Launcher. So for this reason, for us, this solution was not the ideal one. So a third option is to use seccomp notifier. So probably many of you are familiar with seccomp, but a very nice feature of seccomp is the notification. So basically, this instead of killing or denying a syscall, you can pause the target socket. And then you have a monitoring process. And basically, this gets notified when a certain syscall is executed by the target process. So this is already integrated in OCI runtime. Basically, you can start monitoring a target container. And then you have usually a preview that can allow, deny, or modify, like, for example, the argument, or inject some result into the syscalls. So there is an annotation that's already supported in OCI in order to pass this file descriptor to the runtime. And at the same time, you need to add to the second profile that it's usually provisioned by the container runtime, the seccomp act notify action. So here we can see some schematics with, in case of Virt Launcher and Virtenla. So first of all, we add the action. The OCI runtime has the file descriptor to Virtendra that is monitoring the syscalls. In our case, the container, the target container is virtiofs, so it executes the syscalls, and then basically Virtenla can react and execute the privilege operation in behalf of virtiofs. So this is a very elegant solution, but we actually saw some problems while we were testing our proof of concept, and this is why we had we couldn't choose this option directly. First of all, there is a problem of resilience. So if, for example, the monitoring process is restarted, it loses the file descriptor where it's getting the notification. So we need a mechanism to retrieve the file descriptor back. So this is possible, for example, if we extend the container shim. So a container shim is a very process that is running alongside the main container. So this could be a way where we could store the file descriptor, and when the monitoring process comes up again, can retrieve the file descriptor back. So this was what the first problem that we saw. The other was a kernel limitation. So the kernel currently doesn't allow to record syscall during the restart. So this is something that we need support into the kernel. So now we are going to the fourth solution.
Well, we have some requirements and some limitations with the current API. Sorry, I will use that. We ended up doing this. I know it's a bit of a sin in Kubernetes, but what we really want is also support for a safe file handle for non-privileged process in the kernel, but we don't have that. So the way that we need to solve this problem, because as I mentioned before, we really need privileges in virtuofs, is to use like a dispatcher process and a companion. The idea is the dispatcher will join all the namespace and C groups of the container that you want to run inside, and run a privileged binary, a process from outside the container inside of the container, basically. So this is the general idea and schematic. The idea is the Virt handler will execute the dispatcher. Currently, the dispatcher is running inside of the Virt handler container. Then it will find the process ID of the virtuofs container, the process ID of the main process inside of the container, that is the pit number 1. And then it will join all the namespaces, well, not all, the namespaces and the C groups of that. we also need to reparenting that process inside of the container. So now the pid number one inside of that the pid namespace is the new parent of the new privilege process. It will forward the standard out and R to the pseudo terminal and then execute the target process that in this case is virtuofs. So this solution is also, I will say, even is scary, it's very nice. Doesn't need to refactor anything on virtuofs, although we plan to make some modification in virtuofs to make it easier to do some of this stuff. The process is running inside of that container, so it means in the same C groups, so all the resources are allocated and accounted to the vir launcher, and also the lifetime is linked together. The problem is it doesn't respect the formal OCI container boundaries. It means in this case it's not really problematic because this container is created by the qvirt infrastructure. But for example, if there was like a normal user container when you need to you want to define some seccomp filters, those are completely ignored for this process. And also requires the implementation in dispatcher and like a dummy PID1 inside of that container that do basically nothing, just wait until the virtuofs dies. So in summary, we tried many solutions. We only presented like a few because also we tried more. We really wanted to use seccomp notifiers because it's closest that will be the ideal for us, but that requires some changes in the kernel and also in Kubernetes. And, that probably we will do in the future. Also for our particular use case, that requires some changes in the virtuofs code because we cannot trust the binary running, so we need to sign cryptographically the file handle that will send. So when we receive the file handle back, we know that was not forged. So we thought that currently the dispatcher could be a valid intermediate solution until we get all the things that we need from the kernel and Kubernetes. And that's it.
Thank you.
I probably just missed this, the seccomp notifier. The issue is that when you restart the container, that it's a different set of filters, I assume.
No. The problem is with the monitoring process, because this is a specific, it's not really a problem with the seccomp notifier. It's a problem that seccomp notifier is inside of Kubernetes and how qvirt works.
You don't have a single instance per container, or? No,
it means that the monitoring process could die at any moment and will be restarted by Kubernetes. But when it dies, we have two issues. One is not related with seccomp notifiers. We need to some way recover the file descriptor to do the monitoring. And the other problem that we have is if the monitoring process send a syscall and we attended that syscall, but we didn't reply yet. So, and in that moment, the monitoring process died. We don't have any way to recover that from the kernel. When we recover since you developed that, we can only recover all the requests that are in the init state. But if it's not in the init state, the request, we don't have any way to recover those that are on fly. So it means that if we keep the file descriptor open, the monitored process will block forever, basically.
And it's a standard pattern in qvirt. So virthandler could be restarted, so the privilege.
Yeah.
So we really need this recovery mechanism for containers.
Yeah, so I don't understand why you can't just sidecar the virtiofs and just give it the capdac search, because Kubernetes can just drop the privileges for everything else and then have the sidecar which inherits all of the C groups and all the things, and then you just give it capdac search, and it's limited to its mount namespace, so it's safe, right? And the only elevated thing that it has is the ability to do the file handle thing, which is a very limited capability. So I don't understand why that's not like a valid solution. Is it that you don't want to provide that capability to inside of the container, or what?
Yeah, so Kubernetes has also some default profile. So if we add capability, we don't want to add capability to virt launcher, basically. because
Okay.
it could break some Kubernetes profile, especially because Virt Launcher is untrusted, so the namespace where it's running should have low Kubernetes security profile.
Right, but Kubernetes separates every container inside of the pod. So the launcher would be restricted because it's inside of its own namespace. The only thing that it shares is like network namespace and the clock. And so you can have an untrusted and a trusted container inside the same pod because Kubernetes separates them, right?
Yeah, but we found some configuration that people that allows the user to enter to that sidecar container. So that was the main problem. And also in other configuration, we found that is the security profile of the whole cluster prevents to give any capability to. So it means it will work on some containers, it will not work on some clusters, and another cluster.
Got it. So you can have a cluster-wide security setting, and then it just, okay, I
Exactly.
understand.
Any other questions, comments? We have a couple of minutes more. All right, going once, going twice. That's it then, let's thank the speaker, thank you.
Thank you.